All right, section 11-3, surface areas of pyramids and cones. So we've looked at prisms and cylinders, and we looked at the surface area and volume of each of those. Now we're going to go ahead and look at the surface area of pyramids and cones. So a pyramid is a polyhedron in which the base is a polygon and the lateral faces are triangles with a common vertex. So we could have all sorts of different kinds of pyramids. The only requirement is, well, the faces are triangles. They meet at the top. All right, so a regular pyramid has a regular polygon for a base, and its height h meets at the center of the base. So in our diagram here, the center of our base, and that inside is h. And the last of the vocabulary, the slant height, the length of the oblique lateral edge. So I like to think of slant height is, if I took a marble at the very peak of my pyramid, that vertex, and rolled it down the side and hit the midpoint of one of the sides, that's the slant height. We call that L. This right here coming down, that's L, our slant height. Next, let's find the surface area of a pyramid with a square base. So what I'd like you to do is draw a net of this. Find the area of each of the four triangles, and then find the area of the square on the base. So draw a net, find the area of that square on the base, and then find the area of each of the triangles. So one thing we need to do is, do we necessarily need that height? Well, we kind of need it, because I need to figure out what this slant height is. So I'm giving this 321. This length is going to be half of the base, or 150. And I can figure out that slant height using Pythagorean theorem. So go ahead and do that. Draw the net, find the dimensions of the triangles, and the area of the triangles, and the area of that square. All right, so our net is going to look something like this. We have a square base, so all the sides are the same at 300. And then we have 4 congruent triangles. So I can easily find the area of this square here. That's going to be side length squared. So 300 to the second power. And I get 90,000 as the area of the square base. And then I want to figure out the area of one of those triangles. I'm going to do 1/2 base times height, and I know the base is 300. I need to figure out that slant height so I can figure out the height of this isosceles triangle. So that's 150. Right? And we're given that this is 321. So I'm going to pop that out. 321, 150. It's always the hypotenuse that we're looking for the slant height. So, Pythagorean theorem states we have 150 squared plus 321 squared equals x squared. Okay, x squared equals 125,541. I take the square root of that. X equals 354.3. In this case, we're talking about feet. All right. So that is the height of these triangles. So plug in that height right there. And you get the area of one of those triangles is 53,147.6 square feet. Those are both in square feet. And I know that there are 4 triangles attached to this square. So I'm going to multiply this by 4. I get the lateral oblique edges, 212,590.4 square feet. And I can add that to the 90,000 square feet that makes up the base. And I get a total surface area of this pyramid at 302,590.4 square feet. So there is a formula for the surface area of a regular pyramid. And it involves the same thing we were talking about with cylinders and prisms. We need to find the area of the base, right? But there's only one base in the pyramid, so that's the area of the base, right? And it doesn't matter what type of polygon we have, right? We can calculate the area of that base. The one thing, it has to be a regular pyramid. And then this is the perimeter of the base. And the other one is our slant height we need to know, going down the side. So let's find the surface area of a pyramid with a hexagonal base. Ooh, a hexagon. Each side length of the base is 6 meters. So to use this formula, big B plus 1/2 perimeter times slant height. So we need a couple of things. Big B, perimeter, and slant height. So we're given the slant height. That's kind of nice. 8. So now I just really need to figure out the perimeter of the base and the area of the base. So the perimeter, each side length of the base is 6. There is 6 sides, so the perimeter is 36 meters. Now the area of the base. So I can use 1/2 of pi times perimeter if I want. Or our knowledge that our regular hexagon consists of 6 equilateral triangles. So I can use the formula for one equilateral triangle. To go ahead and calculate the area of this whole thing. So I'm going to use square root of 3 divided by 4 times 6 squared. That's the area of one of these triangles, this triangle in blue. And then I can multiply that by 6, because there are 6 of those triangles within my regular hexagon. So that's going to be my area of the hexagonal base. I'm going to put that right there for my base. I get 93.53 meters squared. And then I can calculate my surface area. Big B, 93.53 plus 1/2 times the perimeter times the slant. And I get a surface area of this hexagonal pyramid. .53 meters squared. Remember now that we're back in surface area, it's not meters to the third power, it's meters squared. Questions so far on this? All right, next I want to figure out the surface area of this square pyramid. This is not in your notes, but I'd like you to go ahead and give it a try. All right? Use the formula instead of the net for this square pyramid. And so surface area equals big B plus 1/2 perimeter times slant height. So go ahead and take a second, give this a try on any scratch piece of paper. Recorded. So the things I need to find. My base, perimeter, and slant height. So I'm given the slant height is 5. The area of the base, since this is a square, is 6 times 6, or 36. The perimeter is 6 plus 6 plus 6, or 4 times 6, or 24. So now I can plug this in, and I get 36 plus 1/2 the perimeter of the base times the slant height. I get 36 plus 12 times 5 is 60, or 96 inches squared. So not difficult, just finding those three things and using that formula. The next thing I want to look at is the surface area of a cone. So a cone has a circular base and a point that is not in the same plane as the base. And notice the surface area formula for a right cone, right? So a right cone means that the center of this circle and the radius will make a right angle with the vertex, right? So the surface area formula for a right cone, very similar, but instead of 1/2 perimeter, we can rewrite this as the big base plus 1/2 the the circumference times the slant height. So the same exact formula, and we can take this one step further like we did before. Go ahead and plug in, since this is a circle, we have pi r squared. That's the area of our circle. That's the big B. Plus 1/2 2 pi r times L, right? 2 pi r is the circumference. And I can take this even one step further. I know 1/2 of 2 is just 1, right? So the surface area of a right cone is actually pi r squared plus pi r L. Go ahead and try to find the surface area of this cone. Notice, again, I'm going to need to do Pythagorean theorem to find that slant height. So take a second, find the radius, the slant height, plug it in, get the surface area. All right, so let's go ahead and use our Pythagorean theorem to find the slant height. So in this case, I have 3 squared plus 4 squared equals that slant height squared. So 9 plus 16 equals L squared. L squared equals 25. L equals 5. So there's my slant height. And now I'm going to use this formula right here. So I have R, which is 4, the slant height, which is 5. So the surface area, pi times 5 squared plus pi times 5 times, pi times the radius of 4 times the slant height of 5. And this is actually, my bad. This is 4 right here. So there's our radius. So our radius is 4. Plug that in there and there. And then our slant height is 5, and we can simplify this. So 16 pi plus 20 pi. We end up with 36 pi. And we're going to use the pi button in our calculator. Go ahead and estimate this. So 36. I get 113.1 square feet of surface area.